Okay, I want to talk about the relationship between the exponential and the log. So what we're going to do is graph both the exponential and the log with the same base, because we know we can go back and forth between the two. And we're going to give the domain and range of each. So, first one, the y equals 2 to the x. When I ask you to graph this, what do we do?
Looking at x, y, 2.
And what numbers do you plug in?
0, 1.
Okay, what's 2 to the negative 1?
0. Or 0.5.
1/2, it just flips it. 2 to the 0, and 2 to the first?
2.
Alright, so we can practice. Negative 1, 1/2, 0, 1, and then 2. So remember these, it had a horizontal asymptote at 0, so it didn't actually hit that. What's the domain of this? Domain is from left to right, it keeps going both directions. The range is the y's. Now let's talk about the log. We have not graphed a log, but we can, let's change this into exponential. So we did this definition last week. So this means 2 to the y power equals x. So this is an exponential. When we graph an exponential, we always plug in negative 1, 0, and 1 for the exponents. What variable is my exponent? It's the y this time. So I'm going to plug in negative 1, 0, and 1 for my y. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. What happened to these points? They flipped. Alright, let's go flipped. So 1/2, negative 1, 1, 0, 2, 1. And graph this. What kind of asymptote do you think this one has? A vertical. The other one had a horizontal asymptote at 0. This one has a vertical asymptote at 0, which we've already kind of discussed with the log. I told you that it always had to be, the argument had to be greater than 0. What's the domain?
0, 2.
What's the range? So, all of my ordered pairs just flipped. My domain and range just flipped. What are these?
Inverses.
They're inverses of each other. So that's why the exponential has a horizontal asymptote and the log has a vertical asymptote. They are inverses of one another. All right. Whenever I ask you to graph logarithms, we will actually change it to exponential form and graph it like we would an exponential. We will still do parent functions and transformations like we've done with those exponentials. So that is our next example. Have you done what they need here? So let's say I ask you to graph this.
Super sticky on my table.
Okay, so if I wanted you to graph this, f of x is the same as y. So if we change that to exponential form, it's 1/3 to the y power equals x. So when we graph these exponentials, we do 3 points for the exponent. My exponent is y, so I'm putting in the -1, 0, and 1 for the y. What is 1/3 to the -1? 1/3 to the 0. And 1/3 to the first.
1/3.
So now I can plot these points. And we should have a vertical asymptote, so make sure when we graph this, we're not actually hitting the y-axis, it's an asymptote. So it should look like that. Yes, ma'am.
Is there a way to check them on the calculator?
Not a very user-friendly way because of the base issue. You have to go into actually the catalog of functions to get the different options. You're welcome. All right. Let's do another one.
Are we gonna have to know the domain and range for all of them?
I might ask you if, let's do that on the next example, do domain and range. Okay. So let's say I asked you to graph f of x equals log base 4 of x plus 2. Just like with those exponentials, the -1, 0, and 1 were points that we would put in for our parent function. So we do have to go ahead and think about parent function and transformations here. I would ask you to graph both. So what would be my parent function? It's just the regular log. Y equals log base 4 of x. So in exponential form, that's 4 to the y equals x. Okay, so our points, you're putting in -1, 0, and 1 for your y. What's 4 to the -1? 4 to the 0? And 4 to the first?
4.
So we have 1/4. So this is my parent function, so I'm going to draw that dashed. Now, my transformation, what does this +2 do?
Left 2.
If I move left or right, what else is going to move on this?
Asymptote.
Because we have a vertical asymptote. If I go left 2, my vertical asymptote is now at -2. And then we can move each of our points over. So it looks like that. What is the domain of this?
-2 to infinity.
What's your range?
-infinity.
Good. Let's do another one. If I asked you to graph log base 4 of x, and I wrote my plus 2 like that.
Up to.
Right. This has the same, guys, this has the same parent function, so I'm not going to go through that whole process. Can I just draw it on the same graph? Will that confuse anything? So we're taking that original one and moving it up 2 this time. So same transformations we've done before. Does my parent function move there? Or sorry, does my asymptote move there?
No.
No. What's the domain of that?
0,
For the orange one, it's just 0 to infinity. And the range is always on these negative infinity to positive infinity. Okay.
Is that the orange line?
Yes. Let's do another one. Let's say I asked you to graph log base 1/2 of negative x. So is this the same parent function? No. So we have to find our parent function again. So this is, think y equals log base 1/2 of regular x for your parent function. So it'd be 1/2 to y equals x. So for your exponential, you plug in -1, 0, and 1 for the exponent. So that's the y. 1/2 to the -1, 1/2 to the 0, 1/2 to the first. Function. If a negative is on the x, so it flips over, it's like making the x negative. So if I went through and made these x's negative, it flips it over the y. If the negative were out in front of the log like this, that would be making your y's negative, so that would flip it over the x. So if it's out in front, it flips over the x. If it's attached to the x, it flips over the y. So you just reflect each of those points.
Can you explain that again?
Mhm.
Like, how do you tell the difference?
So this negative is on my x. So if you think about this point, 1/2, 1.
Mm-hmm.
If I make my x negative, then it goes to negative 1/2. So 1, 0 will go to negative 1, 0. 2, -1, if I make the x negative, it goes over here. What is the domain of that one? Range. And the range will always be negative infinity to positive infinity. Any issues there? Last thing I want to talk about is finding the domains of these logarithms without drawing a graph. So we've done it by drawing a graph, which is great, but you don't have to draw the graph to get the domain. Because what have we already decided with
The range is always
the range is always negative infinity to positive infinity. And when we wrote down the definition of these logs, what kind of number did I tell you this argument had to be? Positive. So if I'm asking you to find the domain, Whatever is in here has to be positive. So that means x minus 1, positive just means greater than 0. So x is greater than 1. Greater than 1, how would I write that in interval? 1 to positive infinity. Okay. B. This minus 1 on the end just moves my graph up or down. Does it matter? No. So all you look at is the thing you're doing the log of has to be greater than 0. Okay. C. Kind of trick you a little bit here. So this is saying like the absolute value of x has to be positive.
Which
It always is, except there is one number that x can't be. 0. Because we can't do the log of a 0. The absolute value makes it always positive, but we can't have 0. So I want everything smaller than 0 and everything bigger than 0. The only time that would ever happen is that absolute value there. All right. One more.
What if there was like a plus, what if there was another number in with the x?
Then, so if it were like x plus 1,
Yeah,
it would be everything except 1. Or, sorry, negative 1.
okay.
So you have to figure out what made that inside the absolute value 0, and that would be the thing you couldn't have.
Okay, yeah.
All right, G. So x squared minus 4 has to be greater than 0. Okay. So remember when we did these problems, the quadratic inequalities, we looked at a graph. We figured out positive 2 and negative 2 are the 2 times it equals 0. What does, go ahead and graph x squared minus 4.
That just goes down.
So I'm trying to figure out when this thing is greater than 0. So it started out greater than 0 was positive, so it was above here and here. Could you plug in something between negative 2 and 2? No. I mean, we could into the x squared minus 4, but if I put in like a 0, then I get a negative 4 in here. Can we have that? No. So the answers that work, the ones that make it above 0, is everything smaller than negative 2 and everything bigger than 2. So being negative infinity to negative 2. So I did C and D just kind of remind you of some of the inequality stuff that we've solved previously. But in general, if I ask you to find the domain of a log, you just have to take whatever is in your parentheses greater than 0. And
What's ln again?
Natural log is just the same as saying log base e. Any other questions?